both electronic and nuclear degrees of freedom. So it is a big challenge, and even small step is a substantial achievement.
All right, so I have the photopolymerization of cyclohexasilane. What do I do now? All right, so you can see here, start with the product here, and then eventually we want to get to crystalline silicon. So CHS is a 6-membered ring, S6H12. And then it's first altered by UV radiation into its polymer form and eventually into the crystalline silicon. It undergoes a process called photo-induced ring opening polymerization. It has the ability to break the Si-Si bond to form our polymer. It can be used for many things. It's like the base material for microelectronics and photovoltaics. And it can be altered to produce semiconducting properties. These products have applications in microelectronics, transistors, circuit boards, and then eventually solar cells as well. Can improve our lives drastically. So my question that I started with was increasing the intensity of the UV laser, increase the average bond length, therefore assuming that it does undergo the ring opening property. All right. First here, you can see this is our ground state here going on, and then we want it to do to jump to the excited state through the radiation of the laser. Methods used: we use MATLAB. Code was ran using a lot of Dimitri's help. We have the initial Gaussian at time 0. The initial momentum was set to 0 as well. Then we altered the n-tau, which is time steps in the code, and then Rabi, which simulated our intensity of our UV laser, and then our expected bond length in angstroms is represented by this equation here. Just a side note, we weren't able to use exact to model exactly our silicon-silicon bonds, but the idea is very similar. So you can see here, this is just our initial position of our wave packet. It's just there, just as a reference. The green line here is our ground state potential, and then the tan line here is our excited state potential. And then the blue and red lines represent the probability distributions for the ground and excited states. So as you can see here, it begins stuck in the ground state here, and then the photo-induced jump to the excited state will happen here pretty quick. Then it propagates forward. Another issue we ran into here is that our window isn't infinite, so at the end there it will bounce back, which really isn't the best thing. You can see there at the end how it's grouping up over here. Results. So I used 10 different experiments, and then the n-tau to Rabi ratio is 1400. So I try to keep that throughout the entire section here. And then this is the average bond length in angstroms. I also have a graph over there. The most success was with our UV laser being set to 2, and our time steps set to 700. It produces our largest bond length, and then assuming that it has the highest probability of dissociating out of the just breaking the Si-Si bond and starting to form a polymer. Then here are a few probability distributions. So right here we are seeing that there's no chance that it does get out of the ground state. You can see here, it's stuck in the well. RABI equals 1, our time steps 1400. The one that I felt like had the most success, the video I showed, it is stuck in the ground state for a while, and then the photo-induced jump to the excited state happens here. Then I got another one here. Intensity of the laser equals 5. Time steps 280. And then our UV laser is 14. Time steps.
Can you previous one?
Yep.
So at which time it promotes from ground to excited on the blue? At which time you switch the potential from ground to excited?
About 15.
Okay, and then you switch back from excited to ground?
Pardon me?
And then you switch, wave packet switched back from excited to ground. At which time?
Right about 50 here. It starts to jump back.
Or a little earlier?
What's
like
that?
15 times 2, maybe at 30, when it starts deaccelerating, braking?
Okay. Right here.
Okay.
Yep, and then the larger I increased the UV laser, the more back and forth it was between the ground and the excited state. Got one more here as well. And then finally, in conclusion, I found that there was a really small window that I did find that did produce the highest probability that the bond length did break. The intensity of the UV laser may only increase slightly for it to work. And then through further applications and advancements, we can use these to improve our lives greatly. Microelectronics, photovoltaics. Yeah. Any questions?
Well, thank you, Sam. Before going to questions, let me ask you if I summarize your findings well. First, you didn't compute overall polymerization. You were trying only on the first step of like ring opening.
Yep.
And second, your finding is that you do not need very intense laser. You just need mid intensity for sufficient interaction.
Yep.
So questions to Isaiah? No one? Please.
So on your video,
Yep.
The dynamics, I didn't really see where the wave packet went back to the ground state, and also I don't understand that the excited state seems to be lower in energy at that point than the ground state is. I'm confused what that means. You skip like halfway through.
Yeah.
The excited state is like the mustard color.
Yep.
So now it went underneath the ground state energy.
In this example, it doesn't transfer back to ground.
And then what does the RABI mean in this case?
Main question.
Just be the intensity of the UV laser.
Let me help.
Yeah.
It is how quickly it bounces force and breath between ground and excited, and here it is like half cycle. Full cycle will be going up and down. Okay. More questions to Isaiah? Do not upload yet. Do not upload. There is a common person before Alex. It's the only chance, so it's personal message about your project. In the project that Isaiah was doing, the wave packet was completely propagated from ground to excited. But if it will be even lesser intensity of laser field and shorter pulse, it would promote only part of the wave packet from ground to excited and let it move. And then if after some time you can apply second pulse and promote another part of wave packet into the upper potential. And then you will create two Gaussian potentials in the ground state that may collide into each other. Make sense? Last chance to ask questions to Isaiah. If no, I thank you once again.